what we're going to do is try and build our own little coding assistant, just at least give it a taste of doing that, because right now there are a lot of coding assistant products, but in my opinion, in my opinion, they're not open enough and not scriptable and programmable enough. I want to build one that's my own. So that's my little pet project. And of course, I'm going to use Dagger. Who here has already built an agent? Or is in the process of building one? Okay, so this is a really fun time for me because we're all kind of discovering it. I mean, some of us are a little further along, but let's be honest, we're all figuring it out. And so there's no such thing as a complete beginner anymore. We're all beginners. When I learned about agents, this is what clicked for me. An agent is really software that you plug to an LLM, right? And the best way to think about it is there's a new primitive now in control flow when you write software, right? You can branch, you can loop, you can call functions, and now you can run an agentic loop or an LLM. An LLM is given a bunch of functions to call, and then it decides based on its context and prompts which ones to call with which arguments, and then it can keep doing that, hence the name loop, until it decides it's done, right? This chart is from Anthropic, but everyone has standardized on this system. That's what makes agents so cool. This is the practice of tool calling, right? You have a crazy person inside your code now, and it can call the things. It can mess with your application's environment. As you orchestrate a bit larger and larger systems, things get worse, right? Okay, who is at this point recognizing this and thinking, yes, this is a real problem? Okay, for everyone else, trust me, it is a real problem. But hey, what if we did the same thing that Docker did with insane pieces of code and just kind of put that little crazy LLM in a little jar? And then we controlled what the jar is connected to, so we're in control of which LLM has access to which tools and which context, and you can kind of build on solid ground, right? And so that's kind of what we're trying to do here, encapsulate this primitive in such a way that it can itself live inside your code, right? So you can have LLMs all the way down. LLMs calling tools that maybe also call LLMs that also call tools, right? And I think right now as a community, we're still figuring out that architecture. So this is how we're approaching it with Dagger. We're a platform, very modular, lots of building blocks. So we're like the Lego system, and then you pick and choose what you like to build your own custom system. And people have used that for assembling CI/CD pipelines, like complicated builds, complicated tests, builds and tests of regular applications, build and tests of agentic applications. And then eventually some of them started using it to run the agent itself, because agents are really this, right? They're reusable components that ideally are not insane, but they interact with each other. This is a DAG. Dagger is a platform for running DAGs, hence the name. Okay, hopefully I didn't lose everyone. So we want to replace this interlocked network of crazy people doing crazy things to your environment with a clean modular system where agentic components can actually be composed and form a larger system. So now, there's a choice to make. I could show something safe or show the daily builds that may or may not work, but it is really cool. I really want to show it. So I hope you choose the unsafe option. Do you choose the safe or unsafe option? Unsafe. Unsafe. Okay, nice. My kind of crowd. So are you familiar with the demo gods?
Yes.
You know, you have to make a sacrifice to the demo gods. Okay, so I here have this apple. It's freshly washed, I promise. I need someone to bite into it. All right. Thank you. Okay, everyone's a witness. Okay, let's do this. Okay, so I apologize. And oh, by the way, if the demo is really terrible, you know where the emergency exits are. So, okay, so I'm in my little project that I'm developing. It's a Hello World app, whatever. What I'm going to do is call Dagger. This is remote connecting to my Dagger engine in my home server. This is just my excuse for why it's taking a little longer to load. Okay, I have this thing called the Dagger shell. This is what I use to orchestrate, to automate my tasks, right? So if I need to automate tasks with regular Unix commands on one computer, I use bash or zsh. If I want to orchestrate more complicated tasks with modern primitives like containers, Git repos, secrets, service endpoints, and now LLMs, I reach into the Dagger tool and I orchestrate that. I can do that from the command line, but then later, if we have time, I'll show that you can do it with code also. And that transition between shell and code is the foundation of any lasting platform ever since the days of Unix, right? What were the two pillars of Unix? C and the shell. You had a programming environment with system APIs, and you had the shell, right? An interactive command line environment that could use the same underlying composition model. And it all boils down to composition. So let's say, for example, I want to run a container. I want to run a container from Alpine. Is this big enough?
Yes.
From Alpine. And I want to, just to show you what you can do with Dagger, I'm going to add a file called hi.txt. I'm going to say, hello, AI demo day. And then notice how I'm typing, like chaining functions together in something that looks like a bash command, except it's not. Then let's open terminal. So now you can see on the fly, it built a container for me from the right image, added the right file, and now I'm in this, I have a container, why not? If I leave, okay, it's gone. Let me save that container for later in a variable. I'll call it base container equals this. Who's familiar with this syntax? I don't know. For me, this is the most, like I grew up with this syntax, but I don't know what you all grew up with. This is bash. It's just a regular bash syntax. Okay, now I'm going to, what I'm going to do, load the source code of something, like load the current source code in the current directory, access the host, and get the current directory. Notice that everything is sandboxed by default, so unless I specifically say I want to reach into the host, in other words, this computer, not the matrix, I'm not going to get it. It's all sandboxed by default. Very important if you want to run these very complicated, repeatable builds and tests. And it turns out very important if you're going to orchestrate any of this with an LLM, because you don't want your LLM just randomly accessing your computer by default, right? Oh, were you doing that? Maybe you should not do that. Okay, so now I'm just loading that source directory, and I can combine them myself. But actually, what I'm going to do is, instead of exploring the Dagger API myself to show you, I'm going to switch to prompt mode. And now I have an embedded little LLM that has ambient access to my context. So I set two variables. Normally, did you finish that apple? Okay. Normally, that the LLM has access to these objects and can do stuff with them. So for example, I could say, hello, I gave you a source code directory. Do you see it? By the way, the GPT-4 is because it detected on my machine that I had OpenAI API keys, but I also have Anthropic API keys, so I could switch. Cool. What did I put in there? I forget. Oh, it's my hello world. Do you also see a container? Okay. Notice that these weird IDs, that's the underlying object system. It's the state of my Dagger engine. So every object in the Dagger engine, every container, every file, every LLM context is an immutable content addressed object that you can transform by calling ephemeral functions. So you're building a graph of objects as you go. So it's a totally different way to think about compute than traditional operating systems like Linux. But it's the only way to build an application in a way that will scale to the amount of scale and revolution speed and just complexity of an AI agent. So, okay, cool. I want you to, so far this is not super useful. Please explore the source code and figure out, and I'm just not figure out how, just do it. And build a dev environment capable of building and running it. Start from the base container I gave you. Okay, so what's happening now is, since everything in Dagger is typed, it has an API. When I gave those two objects, that container object and that directory object, to the LLM, it actually it got bindings to the underlying API that turn into tool calling automatically. So if you're familiar with tool calling, right, it's the stuff I was explaining before. So now it's basically going in an agentic loop. Let me switch to web mode. So everything that's going on in that session is traced by default. So there's deep traces going up to the cloud, and I can go and here look at the whole session in that view. So here you can see that's my prompt from before. Please explore. It's thinking, it's looking at objects. Now it's looking at the contents of my directory and it's figuring out, oh, this is a Node.js application. Okay, now it's combining, it's composing on the fly by calling these functions, my container, my directory, and it saved it to a new variable called dev container. And now it tried to install stuff and it's messing up, thinking, messing up. It's very common with agents. Okay. Oh, there's a persisting issue. Don't worry about that. Just give me what you have. Yeah, don't tell me, just save it to me. Okay, so now I can switch back to shell mode, and it said, oh, I put it in dev container, right? Did it call it dev container? So now I can access that new variable that I have, and it's a new container that was built by the assistant. So I just go and open a terminal and see what it built. Oh, that's the same as before. Wait. That's no good. I open the container and it's not, hey, please set the work tier so I can see the files when I open the container. So obviously we're messing around and doing something that's super useful. The point is, these kinds of agentic behavior, right now, if you want them, you're kind of stuck in between two extremes. You can learn a full-blown framework and build a full-blown application and develop the perfect AI, coding AI from scratch. And then you can keep evolving it. And it's very fun and rewarding, but it's not very modular. It's very monolithic, right? And it's also kind of a steep learning curve. Or on the other end, you can stick to the apps, right? Claude Desktop, Claude Code, Cursor, Windsurf, and from there, these tools have some built-in agentic capabilities. They're rushing to add more, of course. Why would they not? But at some point, when you want to customize, what do you do? What would you do in that situation? Is someone in that situation? You're using Cursor. You want to customize your agentic workflow. What would you do? Okay, well, usually someone is like, what about MCP?
I was going to say that.
Thank you.
You said MCP.
Okay, there you go. What about MCP? Well, MCP is great. In fact, you can expose all this as an MCP server if you want. But the problem with MCP, at least now, is that it's like Heroku add-ons. Remember those? They're monolithic sets of tools. So you go and choose the sets of tools that you want and you run them. And that's like plugins. I think actually it's great. It's perfect for Goose, perfect for those apps. But then at some point, you go beyond what an app, even with all the plugins in the world, can do, because you want to compose, right? You want to do what people have been doing for 50 years in the shell. You just want to compose. And MCP does not allow for composition because the code is locked in, and the app also locks in the code. And now you still have that gap. And on the other side is the framework. Okay, is this so custom that I'm going to learn the framework? Well, our goal is to kind of provide an in-between. that kind of integrates neatly with the frameworks once you want to go there, and with Goose and MCP if you're still on that side, So that's the idea. Meanwhile, while I was stalling, it fixed a work here for me, so it says, and it saved the container back, so I can go back and try and say, okay, 2 minutes, perfect. Now when I see what I did, I opened the same as before, open a terminal, it's all in there. NPM, I'm hoping NPM is installed, that's the bare minimum. I'm actually terrible at, I don't know the stack, so I don't know if it did a good job, but if it didn't, I would tell it to iterate. And then, I would say, great, let's save it to a registry or publish to something. Okay, with the time I have, I'll just glance at something. Once I'm done iterating in shell scripts, let's say I have the perfect build that the agent figured out for me, perfect container. Eventually, you want to move that task from the LLM to code, right? Like that line between what you want the LLM to do, what you want the code to do is very fluid, very dynamic. And so that's where you whip out your IDE, you choose an SDK, and the most satisfying part that sadly I will not be able to show is that all these commands that I typed, I can just turn them into code that do the same thing, the same API, write maybe 20 lines of Go. I would use Go. Some people on my team use Python. And then you publish that, and you give that for the LLM to call. And so gradually, you're kind of building your little collection of components, and you give it to the agent to orchestrate. And then you figure out new ones to build, and it's kind of this nice back and forth, LLM to code, code to LLM. I'm painting an abstract picture right now, but if that's the kind of problem that you're interested in discussing, that's really why I'm here. I just want to start some fun conversations. Just a weird middle ground between using an app and writing an app. There's a middle ground there. If you want to talk about that, come find me. And that's it. Thank you.